everyone. So next we will go with SunQuest, which is a smart solar tracking system. It is a system which is designed to utilize full source of energy. Like there are solar panels installed everywhere in the world, but sun travels from one direction to another direction. So while traveling, the one side will be wasted. The time will be wasted. So the utilize of that time is very important to gain more and more energy. So this is the system which is used to track the sun and use the most energy from it. Okay, so it is very simple, low cost and automated solar tracking system which keeps the panel aligned with the sun in the real time. Okay, so the goal of this system is to maximize energy generation, and it is simple and low cost and enable real-time solar tracking. Okay, next, what are the possibilities to build this system? First of all, we will use the LDRs. LDR is a light dependent resistor which is used to track the sunlight, and the Arduino, which is a microcontroller, which is the main brain of our system, and the servo. Servo is used to rotate the solar panel. Next, the we will look into the system design. Here we need the components, as I told, the Arduino Uno, which is the brain of our system. Next is the LDR sensors for tracking the light. Next is the servo motor. We can use SG90 or MG90S. Now we are using the SG90. Next, we will use the breadboard for connections of the system. Next, we need to use some wires to connect the components to the microcontroller, and we will be using a USB cable for uploading the code to the Arduino Uno. Next, we will use one mini solar panel and the LEDs for power generation. Next, we will look into the Arduino Uno. Arduino Uno, as I told, it is the brain for our system. Here we have multiple digital pins, and here we have analog pins. Here we have the power circuit. From this port, we will upload the code via our system. Next is the LDR system, LDR sensor. LDR is the light dependent resistor. Okay, here we have the LDR sensor. The whole sensor module with sensor is the LDR sensor module. This alone is the LDR sensor. Here we have the potentiometer used to control the sensitivity of the light. We have here two lights, one for power indication and another one for the output indication, and this has the three pins. One is the output pin, ground pin and the VCC pin. The D0 pin is used as the signal pin to the microcontroller, and the ground will be connected to ground, and the VCC pin will be connected to 3.3 of Arduino Uno. Here you will see that 3.3 voltage is available. Here we need to connect the VCC pin. Next is the servo motor. Servo motors has three pins. The orange wire is the signal pin. Next will be the red, which is VCC. Next is the brown colored, which is the ground. Next we will be having the solar panel for the power generation and the LEDs to indicate the power. Next, whenever we build one system, it is essential to create one circuit diagram. This is the circuit diagram of our system. Here you can see that two LDRs are connected to Arduino Uno, which is basically the signal of the LDR sensor is connected to second pin of Arduino Uno and the third pin of Arduino Uno. Next, we will go with servo motor. Servo motor is connected to D9th pin of the Arduino Uno. Next, the working principle is very simple. Whenever the LDR detects the light intensity from left or right, the servo motor rotates as per the intensity of the light. Wherever the intensity is more, the servo motor rotates in that way. Like this, we will be grasping, we will be extracting more and more energy from the sun, from this solar panel. We will go with the program is very simple. Try to understand that. In order to use this servo motor, there is a library called include servo.h. We will include that library. Next, we need to define the pins where we will be connecting our components. The LDR sensor pin is connected to 2 and another LDR will be connected to 3, and the servo motor is connected to 9th pin of Arduino Uno. We will take some variable which is a delay time of 15. Next, we need to create an instance from the servo library, which is servo. My servo is the instance name. Next, we need to declare on function, which is the smooth move servo. Now this function is explained down here. See here, it is used to rotate the servo in the smoothest manner possible. Okay. Next is the setup, void setup. In void setup, we need to define which are the input components and which are the output component. Here LDR1 and LDR2 are the input components, and there is a function called myServo.attach, to which the servo is connected to be declared from here. Next is the void loop. In the void loop, we need to read down the sensor data. So there is a function called digital read of the pins, LDR pins, which we connect to the microcontroller. Next, we need to print the values to identify which has the higher intensity. Next, we will take one variable called current position to read the servo angle. In current position, we will read the what is the angle of the servo. Next, we need to write our logic. When if LDR value is more than the LDR value 2, the servo must be moved left. Same as if the LDR value 1 is low and LDR value 2 is high, then the servo must be rotated right. Otherwise, it should be stay in the position where it is last stopped. Next, in the new variable, we need to write the current position of the servo motor and the adjust angle. Next, we need to take the new position, and this limit of the servo should be written as 45, 135, because the SG90 rotates 180-degree rotation. So 135 plus 45 is the 180-degree rotation, maximum rotation. Next, we need to serial print the data of new position, like at which position is the servo motor present as now. This is the code for your SunQuest. Next, we will go with the circuit connections and check the output.
Hello everyone. Today we will be starting the connection of SunQuest, which is sun tracking system, in which you can see we use two LDR modules and one servo motor and Arduino Uno. So let's start the connection. So first of all, we should take the 3.3 common in the breadboard. And also the ground. After this, let's start the connection of the LDRs. So VCC of the LDR will be connected to the 3.3 volt, which we have taken common in the breadboard. And ground to ground of the Arduino Uno, and a data pin will be connected to the data pin 2 of the Arduino Uno, and at the LDR 2 same connection like VCC to 3.3, ground to ground, and data pin to third pin of the Arduino Uno, and the servo connection will be, the orange color will be a data pin, red will be the VCC, and the brown will be the ground pin of the Arduino Uno. So let's start the connection. Brown will be connected to the ground. Here the servo motor works on the power supply of 5 volt. So let's connect to the 5 volt. And data pin to the D9. So let's power the circuit. So, as the name indicates, sun tracking or light tracking device. This means where the intensity is more, the servo rotates at that side. So, for example, as you can see, it detects the light intensity here, so it rotates this way. If I do the dark in the other LDR, then it rotates this side. So you can also, as you are learning the AutoCAD, so you can also design a plate which can be used to place the solar. You can you can design a plate, so you can place the solar above that, so it can rotate as where the light intensity is more. So thank you.